Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, profitable schemes. So basically, in this problem, we have a group of n members, okay, and we have a list of crimes they could commit, okay, and then the ith crime generates profit I. So let's say crime 0 generates profits at position 0, so it generates profit of 2, and it needs a group of I to be able to participate to commit that crime. Okay, and so again, for crime 0, we need profit 0, so 2, and we need to group 0 members, so we need 2 members. So we need 2 members out of this n to be able to commit that crime and get the profit. And the member can't participate in another crime, which basically means once you commit crime at position 0, then you should subtract this 2 from this 5, and you would have only 3 members remaining, because they can't commit another crime. If they did, then you could keep 5 and keep reusing them, but they can't, so you'd have to subtract it. And we have this concept of profitable scheme, where basically it's any subset of the crimes that we have that can generate at least the minimum profit that we have here. So the profit of a set of crimes is just the sum of their profit. And so to have a profitable scheme, it's basically a subset of the crimes where the sum of the profit is smaller or equal, is bigger or equal than the minimum profit, but also the total number of members participating in that subset of crimes is at most n, which is what I said earlier about like a member can't commit 2 crimes, so you'd have to subtract it completely. And so the goal of the problem is to return the number of schemes that we can have, and then we could use this modulo. Okay, so that's the idea here. Now let's take a look at the first example and see what this is about. So for the first example, well, we want to get profit of 3 at least. And so we could decide either to do only this one, right, crime at position 1, that will give us profits of 3. It will give us, we will need to use 2 members, which is within the number of members we have available. So that's a valid solution, so we count it, so we have 1. And then the other possibility is to do both, right? You can't do just 2, because then the profit is just smaller than the minimum, but you could do both, and then the profit would be 5, which would be bigger than the minimum profit, so it's good. And then also in terms of the number of members, we would need 2 plus 2, so 4, which is still within the limit that we have here. So that's another possible solution. And since just 0 alone is not possible, then we have only these 2, so it's 2. Okay, so that's the idea. Now, it did happen that this problem here has 2 and 2 that are within the limit. Now, what if this here was, let's say, 4? If this was 4, then we would want to return just 1, because you can't take both. Because if you take both, then you need 6 members, but we have only 5. Okay, so you can think of this as we have 2 constraints. We have the constraint of the sum of the profit needs to be bigger or equal to the minimum profit, but we also have the constraint that the groups, the total number of members in groups we take has to be smaller or equal to this n. Okay, and that's the problem here. Now let's see how we can solve it. Okay, so how do we tackle this? Well, the first thing to think about is there some sort of heuristic you could use to solve this intelligently, or at least without trying all possibilities? And if you think about it, there isn't really anything. And so in that case, we should just try all possible choices. As usual, if we can't find an optimal way, let's just try all of them and then calculate. And so here we want to calculate the number of schemes that we can choose, right? The number of profitable schemes. And so then we need to just think about our choices. Well, for every crime, remember, these are the crimes, and we get the profit array for the crimes, and then the groups that we need, where that contains the number of members we need for each crime. Okay, and so for each crime we have 2 choices. Only 2 choices possible, right? You could either commit the crime, right, or not commit the crime. Those are the only two choices. And so let's just try both and see what we need. Now, what are the constraints that the problem says we need for a profitable scheme? Well, the first one is that the sum of the profits for the subset, right, for subset of the crimes we are taking needs to be bigger or equal to the mean profit. Okay, so that's the first one. The second one is that the number of the members in the group, so the sum of, let's call it group I, right, for the I in the subset of crimes we are taking, right, needs to be within the number of members we have available, which is n. So this needs to be smaller or equal to n. Okay, and so if you think about this now, sort of the state of our recursive function that will need to either commit a crime or not commit has two things. Well, it has first the profit, the total profit of this subset. So it has the profit. Let's call them the profit so far. And it should also have the members that we used so far, so that we make sure that we don't exceed n. And so let's say, let's call this members used. Okay. And what else do we need? Well, when we are looking at crimes, each time we look at the ith crime and decide either to take it or not take it, which is committed or not committed. If we commit it, we get the profit for it, and we need to add the members we needed for it. But if we don't commit it, then we just move to the next one and also decide. And so each time we need to pause at the ith crime and decide whether to commit it or not, and then go to the I plus 1. And so we also need the position. And so now we know the state of our function, which will need to be basically the index, right? The profit so far, so that we can make sure we don't exceed here. And then the members that we used. Okay? And now the only thing left to do is to determine our base cases and then the recursion that we want to do. Now, let's first do the recursion. Well, for the recursion, we can either take or not take. So basically commit or not commit. So if we want to commit, then what happens? So the function calculates the total number of ways, right? Okay, and so let's call it ways then with this state. And so if we want to commit, then we commit this crime at I, and then we want to go to the next index, index plus 1. Now, if we commit the crime, we gain the profit from that crime. So we want to add the profit from that crime, which is going to be just profit at that index. Okay? And if we commit a crime, we use the members in that group, right? So, for example, in the first example, we have 2. If we commit crime 0, then we use 2 members. Okay? And so here is going to be the members used so far, plus the members we use from group at index I, this index here, right? Because to commit that crime and get the profit, we need to use those members. Okay? Now, what about don't commit? Well, don't commit is easy, or don't commit, because in that case, we can just go to the next index, but still keep the same profit so far, right? And the same members used, right? Because we use the same, because we didn't take anything. And so this is, of course, going to be I plus 1 because we go to the next state. And what do we get from these? Well, we want to get, for each state all the way to the end, we want to get if it was valid scheme or not. If it was a valid scheme, we will add it to the number of ways. If it's not, we won't add it. And so let's call this result, and then we will add the number of ways from each call, and that's what we are going to return at the end. Okay. Okay, so now what are our base cases? Basically, the base cases need to determine if, when we reach them, if it's a valid way or a valid profitable scheme so that we can count it. What does count it mean? Well, if we want to count it, then we just need to return 1 so that it propagates to here and gets added as one of the ways, okay? And so the first thing we know that if we reach the end of the number of crimes, right, and the profit so far is bigger or equal to the minimum profit, and the members used is more or equal to n, then that's a valid way, okay? And so instead of checking all of these first, let's just actually just check the invalid base cases, and then what remains would be just the valid cases. So what's one of the invalid cases? Well, if we ever exceed n, then that's not valid. And so if ever the members used is bigger than n, then that means we violated this condition, and so we can immediately return this is not a valid way, so we return 0. Okay? Now what if it's within members used, but we reached the end of the group, so we there is no more crimes to commit or not, which basically means index is equal to the length of the group. Now in that case, okay, in that case what should happen? Well, it depends on here. If the profit is smaller than the minimum profit, then that's not so if profit so far is smaller than the minimum profit, okay, what does that mean? Well, that means it's not valid because we didn't reach the condition of at least minimum profit. So in that case, what does not valid mean? We can just return 0. Okay? Now the other case is, what if the other remaining case means basically here that the profit so far was bigger or equal to minimum profit. And the members used is smaller or equal to n. So that means both conditions are valid, which means we have a profitable scheme, so we should count it. Now counting it just means returning 1, because then it will propagate to the result callers, and then we will add it up and we'll return it as this here. And that's pretty much it. So just try two choices, try the two possibilities, commit or not commit, and add however ways we get from those to our result. And then in our base case, we'll check if it's a valid scheme, profitable scheme, we'll return 1. If it's not, in this case, we'll return 0. Okay. Of course, there are a couple of things we need to do. One is we need to add the mod here, and the other thing is we need to also cache, because if we don't cache, we will call the function multiple times with the same input, and that will recalculate everything. And so we want to cache or memorize in this case. But this is the main logic, so let's just write it, make sure it passes. Okay, so I type it here just what we saw in the overview. So we have our function here, and then what we want to do is we have our base cases here. Sorry about this. We have our base cases here. So if we exceed n, that's not valid. We return 0. If it's equal, then depends on the profit. If the profit so far is smaller than the minimum required, then it's not valid profitable scheme, so return 0. But if it's bigger or equal to minimum profit, it's valid, so we return 1. It's a valid way, so we return it. And then here we have two choices, either take it, and so actually let me just show you here. So we either take it or not take it, okay? So if we take it, then we add the profit. If we don't take it, we don't add it, and then we return the result. And now we need to call it, so we call it with the first index 0, the profit so far is 0, and then the used is 0, and we return this. The other thing we need is, of course, to use the mod here. So let's just define the mod that we need. So 10 to the power of 9 plus 7. And then we will need to just modulo it here, modulo it here. Sorry about that. And then modulo it here as well. And that should be it. Now, if we run this, it does pass on these couple of test cases, but it will first exceed time limit exceeded, because we are first calling multiple cases. This function here, we may call it multiple time with the same input, and then it will recalculate. So of course we need to memorize. That's the first step. And so if we memorize, let's see if that's enough. So memorization, we can use the same state of the function. And so here, if this is in our memorization table, then we could just return it. Otherwise, we need to store it. And so storing it can be just like this. It's going to be the result mod, the mod value, and then we return it. Okay, let's see if this works. Okay, it will probably time limit exceeded. Now, why? Well, because this profit so far plus profit index, every time it will increase every profit you add. But the thing is, we don't care about the profit value itself. All we care about is whether it exceeds, whether it's at least minimum profit. That's all we care about. And so, because here we have 3 states, and so the number of variations with these states increases, because if it's 2, you have less combinations, but with 3 you have more combinations. So can we eliminate one of these combinations? Well, we could we could make this one have less possible values, because we only care about whether it reached the minimum profit or not. And so what we can do is actually take only up to the minimum profit here, because that's all we need. If it's bigger, then we can just pass the min profit, and this check here will pass, and we will get 1. And so if we cap it at min profit, then all the bigger values will have the same value for this state. And that basically reduces the number of combinations by a lot. And so if we use this, this will reduce the combinations by a lot. Let's run it. Let's see if it will pass. And that passes, right? So this is, memorization alone is not always enough. So before switching to DP, normal DP, try to see if there is a way, if you have multiple state, to reduce the number of values that one of them can take, and that will reduce the combinations. I think that's the lesson from this problem. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.